Jet Propulsion Laboratory Auditorium, Pasadena, California. Man is inquisitive, seeks to know. He has explored, weighed, measured, and otherwise examined planet Earth. Now, his ingenuity enables him to probe into space. This is the story of one such National Aeronautics and Space Administration probe. The day was July 31st, 1964. United States spacecraft Ranger was on its way to the moon.
Impact minus 22. Mark, impact minus 22 minutes.
Ranger approaches lunar impact. Engineers in the JPL Space Flight Operations Facility command and monitor its flight. The mission? Take close-up television pictures of the moon. Prepare for the day when man will land there. The Goldstone, California tracking station. Antennas track the spacecraft as it falls toward the moon.
Impact minus 21.
Velocity 4,200 miles per hour, increasing each second. Altitude above the moon, only 1,400 miles.
Magnetic tape recorders were started at 130700 Zulu at both Pioneer and Echo sites. We are anticipating F-channel warm-up at 130719.
Now, at last, man hopes to build his first bridge to the moon.
Station 12, this is Net Control. Command message coming out is for the transmission of RTC-7, and it is to be sent
A spacecraft timer should switch the cameras into warm-up. However, as backup insurance, the RTC-7 command can be sent from Goldstone if required.
Yes, we have it. Command message. Eddie?
Roger.
Many of the scientists who will interpret the pictures have spent a lifetime studying the moon. Today, some of their questions may be answered. Also, new ones may be posed.
Coming up on impact minus 19.
Focal point of the mission is now Ranger's 6 RCA television cameras. The picture signal will be transmitted over 2 communications channels. F channel for full view or wide-angle lenses, P channel for partial view or narrow-angle lenses. All cameras are set for various expected lighting conditions.
Stand by for TV camera warm-up. 60 seconds until warm-up.
These men in operations, every one on the Ranger project, have worked for years just for this moment.
This is Goldstone TV control. At the present time, all receivers on site are go. All kinescope and magnetic tape recorders are in go condition. Clock turn on. F channel is anticipated at 130719 Zulu.
Goldstone, how about Pioneer and Echo?
Pioneer and Echo are both in go condition.
Thank you.
Mark, we have full channel warm-up indication.
Roger.
The RTC-7 ground command not required. TV channel F in warm-up. In 80 seconds, cameras on channel F should go into full power. Begin taking pictures. It's been a long flight, a demonstration of almost incredible precision. 3 days ago, these men monitored liftoff from Cape Kennedy. The booster was an Atlas D. The second stage, an Agena B.
Personnel will remain in position until completion of this launch and stand by for final station check. T minus 60 seconds and counting. JPL ready light on.
Final report, please. Final report.
Atlas, go. Agena,
Go. Spacecraft.
go. Firing is authorized.
Pressurization on.
Stand by.
Minus 30. Start tank pressurization. 5, 4, 3, 2, 1. Ignition main stage.
And the Agena separated on schedule. Agena fired its engine, cut off, coasted to the injection point, fired again, and then separated from the spacecraft. All events nominal. Ranger was on its way. As programmed, the spacecraft came to life, opened its solar panels, locked onto the sun for electrical power. The next maneuver, Ranger rolled, pointed its antenna at Earth. Then, on a command sent from the Woomera, Australia tracking station, the spacecraft switched communications to its long-range directional antenna. Meanwhile, the Deep Space Instrumentation Facility tracked Ranger, maintained two-way communications from Woomera and from the tracking station in Johannesburg, South Africa, processed a continuous flow of information to Pasadena. Within 90 minutes, a first rough orbit was established. Ranger would hit the moon. By 9 p.m., the flight path refined, it was decided that to get the best possible pictures, a mid-course correction was required. Aiming point, south of crater Copernicus, 21 degrees west longitude, 11 degrees south latitude. The spacecraft would cross and photograph a variety of lunar surface features: mountains, flatlands, craters of all types and sizes. Impact would be on a seemingly smooth plain east of the Riffian Mountains. Then, as planned, engineers made calculations for the mid-course maneuver to bring Ranger down in the target area. 3 a.m. Wednesday morning. The Goldstone, California tracking station was locked on to Ranger. An RTC-4 command directed the spacecraft to roll and pitch into a new heading.
Minus 5, 4, 3, 2, 1, mark.
On schedule, the mid-course motor was fired to change the flight path.
RTC-4 initiated at 100000. Roger. Doppler is changing rapidly. Doppler is still changing rapidly. Signal level holding very steady.
Minutes later, Ranger returned to cruise mode. Mid-course maneuver executed.
Doppler rate has settled down. Not changing at this time.
But more hours of tracking were needed to verify that the flight path had been successfully modified. Finally, it was early afternoon. Ranger project manager Harris Schurmeyer announced the spacecraft was on target. All systems were go.
All right. We have completed the first orbit calculation, which has refined the orbit only to a certain degree. And as we make subsequent calculations during the next day or 2 days, we will refine this and pin down the uncertainty in the actual impact location. Now, at this time, we know the the impact location within an ellipse whose dimensions are about 300 miles in the long direction, which is vertically, and about 50 miles wide in the horizontal direction.
The 238,000-mile flight wore on. Camera angles and lunar lighting were carefully studied, and it was decided that no terminal maneuver would be required. The cameras were already perfectly aimed. 10 p.m. Thursday. All aspects of the operation were reviewed. The mission still in the green. Somehow the hours passed, and it was time for the final sequence of events.
Signal level steady. Coming up on impact, minus 18 minutes. Channel F still in warm-up.
The moon, so close, and yet so little known. Of course, most scientists do agree on a few facts. For example, the moon has no atmosphere. Midday temperatures hotter than boiling water. Night-side temperatures 250 degrees below zero. We know other things, for example, the moon's gravity, mass, orbit, rotation. But we don't know one important thing: what the lunar surface is really like. Scientists, astronomers have argued, theories have been devised, and still the arguments continue. Part of the controversy relates to whether the lunar craters were caused by meteorite impacts or volcanic action. Hopefully, Ranger's pictures will be the first step toward ending such arguments, enabling the eventual selection of landing areas. Now it's only a matter of seconds. Engineers in operations wait for Goldstone to announce Channel F full power and Channel P warm-up.
We are 1 minute to full channel power. All magnetic and kinescope recorders are go.
A separate timer in each channel will turn the cameras onto full power. If that fails, the spacecraft's central computer and sequencer will initiate full power.
This is Goldstone TV control. F channel is still in TV warm-up. We are anticipating turn on momentarily. Signal strength from spacecraft is normal. All kinescope recorders are go.
The pictures will be recorded here at Goldstone on both magnetic tape and film. Polaroids will tell the engineers whether or not the TV system is working.
All recording and receiving equipment is operating at both Pioneer and Echo. We are 5 seconds from full power. We have full power on F channel.
Roger.
All kinescope recorders are recording. All magnetic tape recorders are recording. Preliminary look at video appears to be approximately normal anticipated strength. Video on both A and B receivers on the F channel are good. Video is very strong. Video is very clean. This is Goldstone TV control.
The flight continues. The most important pictures to get are the closest ones, just before impact. Now the crucial question: will the Channel F cameras continue to operate, and will Channel P go into warm-up?
We are 1 minute from P channel warm-up. This is Goldstone TV control. Preliminary analysis of the video data indicates normal operation of cameras. We definitely have lunar data. F channel is operational, is excellent signal strength, is excellent video level. This is Goldstone TV control. Preliminary photographic analysis of the video indicates we have good signal strength from the moon. We definitely are able to see craters. Signal strength is very high on F channel. We have excellent video. P channel is definitely in warm-up at this time. We are receiving good signal on the F channels. Video is excellent quality. Signal strength is nominal. We are anticipating P channel full power momentarily. 3, 2, 1. Mark, we have P channel video. We have P channel video. Preliminary oscillograph analysis shows P channel to be excellent signal strength. The signal to noise ratio is approximate.
We're getting pictures from all 6 cameras. Now, if they'll just keep working.
This is Goldstone TV control. On my mark, it will be 8 minutes to impact. Mark.
It will be hours before the actual pictures are in hand. Even at Goldstone, no one knows how good the pictures are. We know only that they are being recorded. Several thousand should be received. The pictures containing useful information will depend on lighting, camera angle, system noise, and other factors.
Mark, we are 6 minutes to impact. We are still receiving excellent video on all channels. We have no indication of any problems from the spacecraft at this time. All video and kinescope recorders are functioning on both sides.
Because of the Earth's turbulent atmosphere, our best telescopes cannot resolve lunar objects smaller than about 1/2 mile in diameter.
This is Goldstone TV control. We are anticipating 5 minutes to impact. We have indication that F channel is going up slightly in temperature, which is normal. All kinescope and magnetic recorders are functioning at this time at both Pioneer and Echo site. All receivers are go.
The lunar plains that seem to be so smooth could be littered with boulders larger than pyramids or battleships. The last Ranger photograph, just before impact, might be as close as 1/3 of a mile, close enough to see objects about the size of an office desk.
We are anticipating impact in 2 minutes. Mark, 2 minutes to impact. This is Goldstone TV control.
The voice of Ranger is piped into the JPL auditorium. Ranger's velocity should be nearly 6,000 miles per hour.
This is Goldstone TV control. We have exceptionally good pictures on P camera at this time. All cameras are functioning from the spacecraft. We have good signal strength from both transmitters. All recording and receiving equipment is operating at both Pioneer and Echo. We have our mark. It will be 1 minute to impact. Mark, it is 1 minute to impact. All cameras are functioning. All video is exceptionally fine. Transmitters are still at the high level. This is Goldstone TV control. This is Goldstone TV control. We'll leave the mic button open at this time. Video is still good. We are some 30 seconds from impact. All recorders are functioning at both sites. Both sites report good data. 20 seconds to impact. All video good. Signal normal. Stand by for impact. 10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact. Impact has occurred at 1325502. Impact has occurred. All video data was excellent right up to impact. All cameras were functioning. Transmitters were functioning properly. This is Goldstone TV control.
Oh, Roger.
The event, now a matter of history. The quick-look Polaroid prints, even better than expected. Engineers at the Goldstone tracking station became the first human beings to see close-up photographs of the moon. 30 minutes later, NASA and JPL officials held the first post-flight press conference. NASA's Dr. Homer Newell, Associate Administrator for Space Science and Applications, was introduced first.
This is an historic occasion. We have just had the very exciting privilege of receiving congratulations from the President of the United States and from a number of congressmen who have been watching these proceedings in Washington. I, however, have no intention of stealing any of Bill Pickering's thunder. This is JPL's day, and and I do not intend to remain on stage here any longer than is necessary to congratulate him, the Jet Propulsion Laboratory, and the members of the Ranger team for what proved to be a textbook operation. Everything on the button. Congratulations, Bill, and the floor is yours.
Dr. Newell and Dr. W.H. Pickering, director of JPL, the two men responsible for Ranger.
Thank you, Homer. Well, this has indeed been a very exciting day. As we all know, it's been a long road, but it looks as though this particular shot has been indeed a textbook operation. I'd also like to point out that there's some discussion here about these Polaroid prints. The final photographs and the quality of the final photographs will be determined by a 35 millimeter film, which will be very carefully processed, of course, and until we get that film, we will not really know what quality we will have in our final photographs.
After the press conference, the Polaroid prints were flown from Goldstone, then rushed to the experimenters in the Space Science Analysis Area. Meanwhile, equipment calibration and recordings completed, the film itself was flown out of the desert country, taken to a laboratory where painstaking tests were made before it could be safely processed. Late in the day, it finally arrived at JPL and was placed in the hands of the impatient experimenters. The second press conference was called at 9 p.m. Dr. Pickering introduced the scientists who were present. Dr. Shoemaker, Mr. Whitaker, Mr. Heacock, and the principal experimenter, Dr. Kuiper.
This is a great day for science, and this is a great day for the United States. What has been achieved today is truly remarkable. We have made progress in resolution of lunar detail, not by a factor 10, nor by a factor 100, but by a factor of 1,000. We have just looked at these pictures for 2 hours maybe, but the first impression which I got is that the records show a continuity of features from the large craters observable with telescopes down to smaller and smaller sizes.
It would take months to interpret the data contained in the more than 4,300 photographs. Even pictures taken as far as 480 miles out from the moon revealed important new details. There were primary craters with sharp raised edges, possibly caused by meteorites impacting at high velocities, and smaller, shallower craters, apparently secondary splashes from the large craters. Down closer, 34 miles from the surface, a remarkable clustering of small craters. 2.3 seconds before impact, still smaller 30-foot diameter and 10-foot deep craters were revealed. A 300-foot rock mass visible in the center of one. The last picture, only about 1,500 feet above the lunar surface. Noise band on the right shows moment of impact. The smallest crater seen, 3 feet in diameter. The best resolution, 18 inches. Only a few hours later in Washington, D.C., Dr. Newell and Dr. Pickering report to the President of the United States. The most significant discoveries, primary craters with steep walls and secondary craters with gently sloping walls. An eroded surface, crater rims generally with smooth slopes and ridges. For the most part, only gradual elevation changes. Almost complete absence of large rocks visible. Lack of apparent furrows and cracks. Some areas of extreme cratering and related surface debris to be avoided in future landings. And President Lyndon Johnson spoke for a grateful nation. Gentlemen, he said, you and your colleagues have taken a monumental step forward, advanced a long, long way down the road to our goal to get men to the moon. You have the gratitude of all Americans of all faiths. What more can I say? You are most welcome at the White House. The people who live here are mighty proud of you. The major conclusion: a large percentage of the impact area topographically favorable for instrumented soft landings and manned landings. It will remain for instrumented surveyors to test the surface strength. The historic flight of Ranger 7. This is the way it was. The day, July 31st, 1964.
We have good signal strength from both transmitters. All recording and receiving equipment is operating at both Pioneer and Echo. We have our mark. It will be 1 minute to impact. Mark, it is 1 minute to impact. All cameras are functioning. All video is exceptionally fine. Transmitters are still at the high level. This is Goldstone TV Control. This is Goldstone TV Control. We'll leave the mic button open at this time. Video is still good. We are some 30 seconds from impact. All recorders are functioning at both sites. Both sites report good data. 20 seconds to impact. All video good. Signal normal. Stand by for impact. 10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact. Impact has occurred at 132550 Zulu. Impact has occurred. All video data was excellent right up to impact. All cameras were functioning. Transmitters were functioning properly. This is Goldstone TV Control.
Oh, roger.
Trailblazed, Bridgehead achieved. Now NASA could send more instrumented probes out from Earth and down to the moon to make scientific studies, to survey the terrain, to select landing areas, to prepare for the time when man himself would walk the lunar soil.